Huh?
Okay, here we go. Chapter 2-6. Parent function is the simplest form that you can have of a family of functions. Parent function, there's several different families. Today I'm going to introduce you to 4 of them. Meet, are you ready?
Yeah.
Very special family. I'd like you to introduce you to the straight
What's
line.
that family with Urkel? It's an old show. Family Matters.
Straight line club right here. Y equals X.
Do we have to draw that?
No.
With our highlighter?
No.
Or what was highlighter for that?
The highlight.
The important stuff.
Can't we just underline?
The next one is the U Club, also known as the very stylish parabolas. Then the next family is a very special family.
Whoever's trying to watch this video online is not going to be able to.
Is the spaghetti family. It's X cubed.
That's a snake character.
And then the last family
There's 4?
is the V family. First one was
Y equals X.
the line family.
The
The
U.
second one,
The snake.
the U. The third one, spaghetti, and the last
And the
one,
V.
the V. Do we all understand this? Yes or no?
Got it now.
Yes? Okay, now, transformation. A transformation is a shift in a parent function.
You know that?
Yeah, you need to know that. However, a translation is a vertical or a horizontal shift. That's important. Okay, all these terms today are very important. Important because you need to know.
I don't know if this orange lasts.
If I have f of x plus the value c, we have what we call a vertical shift. That vertical shift is moved up c units. If I have f of x minus c, then what's happening with that is I'm moving it down c units.
Wait, come on, I need to highlight that. Okay, okay.
So we have 2 types of translations, vertical and horizontal. A vertical is f of x plus c on the outside and f of x minus c. The horizontal one is f of x minus c inside the parentheses, meaning you would think it would go to the left because it's minus. But yeah, that's wrong. You're actually going to the right. Okay? It is extremely happy you're right.
It's unhighlighted, you're saying.
If I have f of x plus c, you would think the plus would mean you go to the right. No.
Like,
It's got to jack with your head, so it's actually going to the left.
like using a turn signal, you put it down, but it means you go left or up.
True statement. So that's the horizontal concept. Okay? Do we understand that? Yes or no? Now, here's what I want you guys to understand. When you have a vertical shift, your y values change. What's that? If I have a horizontal shift, what you have are your x values changing. Horizontal means x changes, vertical means y changes up and down.
You got Yoder.
Now, an example. If we look at this lovely little line of y equals x, And we compare that to the line y equals x minus 2, Raphael. What's happening to it? It went down 2 units. It did. There's 2 reasons why we know this. One, I want you to envision your lovely little XY axis to be Velcro. And you're taking that lovely little line and you're Velcroing it on. Okay? We're not changing anything. We're just simply unvelcroing it and moving it down. Which means every one of my x values stays exactly the same, but I'm going to subtract 2 units off of here. And then 0 minus 2 is negative 2. 1 minus 2 gives me negative 1. 2 minus 2 gives me 0. 3 minus 2 gives me 1, and so forth. Did we see that, yes or no?
Yeah.
What changed were my y values. Did my x values ever change?
No.
No. That tells you why it's a vertical shift. Yes or no? You get that?
Wait.
Because look, when it's a vertical shift, your y values change. When it's a horizontal shift, your x values change. In this problem, did my x values change?
No.
No, they did not. They're still 0,
Only
1,
the
2, 3, 4. Now, here's my parent function, y equals x. Now that I have y equals x plus 5, so what happened to that? I'm going up 5 units. Here I have y equals 3x, and I have y equals 3x minus 10. What's happening?
You're going down 10.
I'm going down 10 units. Do you like my pencil?
Yes.
Do we get that? Mrs. Yoder's very lazy. U means up, D means down, L means left, R means, my dad used to say hang a left, he'd say hang a Ralph for a right, hang a Louie for a left. We're all country bumpkins. Okay, compare the graphs. Here I give you y equals x squared. Right here. You see it? Yes? This one right here is x squared plus 4. What happened to the graph?
Oh,
It went up 4 units.
Share with your friend out there.
It went up 4 units.
It went up 4 units. Well, in order to confirm that, what do I have to check? What's supposed to change if it's a vertical shift? The y values are supposed to change. So how do I check that? If I add 4 to each one of these y values, do they equal the right? So 4 plus 0, is that 4? Yes. 4 plus 1, is that 5? Yes. 4 plus 4, is that 8? Yes. So did the y values change? Which means this is going to be a vertical shift. Moving along.
Have you ever seen the Little Rascals?
I got a pickle. I got a pickle. I got a pickle. Okay, if I have y equals the absolute value of x.
What's that? Yeah. All right.
We have like another slide right here. It says how are the following graphs related? Y equals 2x and y equals 2x minus 3. Yeah.
Oh, well, we'll skip that. We'll get more habit.
I'm still looking for that one.
It's on the next page.
Oh, okay. This is the wrong part.
Well, that's just disturbing.
What did you say?
Somebody just did like a math problem. Hey, look,
They are?
No, yeah.
Is that before that one?
Yeah.
Okay, there we go. I don't know whatever happened. Okay, how are the following graphs related? Here's y equals 2x, here's y equals 2x minus 3. What happened?
It went down.
I go down 3.
Down 3. Here's 5y, y equals 5x cubed, and here's y equals 5x cubed minus 2. What happens?
Down 2.
Down 2.
You ever skipped rocks before?
Yeah.
The most I've ever skipped rocks is like one.
You ever do your math quietly the whole time?
No. I concentrate better when I talk about it. Me too.
You skip the graph.
I'm gonna be doing this.
Okay. Horizontal shifts. Remember to see values inside the parentheses whenever you have with the variable, whenever you had a horizontal shift. If I have the absolute value of x is that one right here, and then this one right here is y is equal to the absolute value of x minus 5, what happens to this thing?
One goes left or right, sorry.
It moves to the right. Why did it go to the right? Because
Because
you
it's a
think
minus
it goes to the left, and it's minus, so it's actually the opposite. So this thing went to the right 5 units. Now, do your y values change here?
No.
No.
No. The only thing that changes are the x. However, because the x values are what change, I'd have to show you 0, 0, and 5, 0. Do you see I can't show you 5, 0 on this table? That's why you can't see it. But you would see 5 and then 0 over here, and you'd see that it was all the same y values. Okay? But in this specific slide, there is no table that I can show you that.
You can slow it down.
I can't. Now, how are the following graphs related? Well, what's happening?
It's going left 2.
It's plus 2, so that means I'm going to the left 2 units because you would think it'd be going to the right.
Yep.
What about this one?
Left 2.
It's going to the right 2 because it's minus 2. You would think it'd go to the left, so it's actually to the right.
Why did I do that? It's a
Confused
mind
you.
game, that's all it is.
Because math is wasn't hard enough.
Okay, now, are we all listening? I want you to, in your mind, visualize x squared. What does x squared look like?
X2.
There were 4 functions that I had that I told you. I introduced you to them. I said, here's the line club. Then what was the next one?
It was the U.
The U's family. And then the next one was the spaghetti family. And then the last one was the V family. Now I want the x squared family. What does the x squared family look like?
U.
A U. So, here's a U. Pretend it's a U. We're not celebrating here, okay? Here's a U. I want you to envision a coffee mug. See my little arm out here? Visualize it. Do you see the coffee mug that you all want to drink hot chocolate or coffee from right now?
So it's like one of those battlefield ones where it's like,
Yeah, we're having a tea party, okay? We all good? Now, if I tell you to stretch, what do you guys instinctively do? Right? And you stretch. Now, here is my U. I want to stretch my U. So where do my arms and my U have to go? Up. Not the travel mug. Right?
Because it fits in her cup holder.
Because it fits in your cup holder in the car. So you're a travel mug. You know what I'm saying?
Yeah.
Okay, I stretch. Now, what do you do with trash? You need to
Throw it away.
step on it, and what happens?
Smash.
It squishes down,
And
right?
widens out.
So here I am. I'm a U, right?
Yeah.
My little handle on my little coffee cup. Okay, I'm a typical normal coffee cup. Now, if you compress me, what happens to my arms?
You break.
They break. They go down, right? So now I'm a really fat mug.
Then they snap.
Or a cereal bowl, right? Or a cereal. Think of a soup bowl or a really big fat one that has lots of marshmallows in it. Yeah, you know what I'm saying? So, a stretch means you are a travel mug. A regular one just means you're a regular old doll coffee mug and nobody wants those. Or you're compressed, meaning you're one of the big fat ones you put lots of marshmallows and all black junk. All right? Is everybody with me? Yes?
Have you seen those thermoses?
Now, so whenever I say stretch, what are you supposed to think of in your mind? Whenever I say stretch, you say travel mug, right? You only have a travel mug whenever you're multiplied by a value greater than 1. Now, what does that mean? Y is equal to AX. Y is equal to AX squared. Y is equal to AX cubed. Y is equal to A times the absolute value of X. Those are all stretches. If the a value is greater than 1.
How would you know if it's greater than 1?
You'll see it. What type of numbers are greater than 1?
Like 2x?
2, 3, 4, 4.5, 5, 36 over 2. Those are all lovely little numbers that are greater than 1. Now, if it's a compression, it can be a compression whenever you are multiplying by a value between 0 and 1. What type of numbers are between 0 and 1?
A half.
A half. Fraction. Why are fractions only between 0 and 1?
Decimals.
Decimals are the same thing. Why are... They're not all whole numbers. There are fractions after 1, but to be a fraction, that means you are part of a whole. And a whole would indicate 1 unit, which would be 1. We understand that. So any fraction after 1 is actually larger than 1. We understand that. Now, y equals ax, y equals ax squared, y equals ax cubed, and y equals a times the x divided by x are all compresses if a is a fraction. We understand that. Okay, for example. The table represents a function f of x. G of x is the vertical stretch of f of x defined as g of x equals 3f of x. What are the corresponding y values of g of x? Wow. If you feel completely overwhelmed. Great, that's what I wanted to do. But now I want you to reread and I want you to think about this. Okay? The table represents the function f of x. This right here is just the xy table of f of x. That's all it is. Do you understand that? If g of x is the vertical stretch, what's vertical stretch?
Up and down.
Vertical stretch. What do you think when you say vertical stretch? Travel log, right? Travel log, right? So vertical stretch is a travel log, okay? Which means I'm multiplying by a value what? Greater than 1. Well, it says defined by g of x is equal to 3 times f of x. Huh. Is 3 greater than 1?
Yeah.
Is that stretch then, or is that compressed? It's a stretch because it's greater than 1. Do we understand that?
Would it be a compression? No.
Patience, no.
Sorry.
Now, it says, what are the corresponding y values of g of x? Now, tell me this. When you stretch or compress something, what changes, x or y?
Why?
Y is the only thing that changes. X does not change. So if they want a table of corresponding y values for g of x, all I'm doing is writing down my x values. And what am I going to do to all of my y values? How do I change them?
3 and then x. You gotta put the 3 for the e.
I got to multiply every one of them by 3. Why am I multiplying all of them by 3? Because it says g of x is equal to 3 times f of x. Do we understand that? So now what is 3 times 2?
6.
3 times 2? 3 times negative 3?
3. Negative 6.
This is my lovely new function g. And I got that xy table by simply taking the xy table from f and multiplying every function, y value in f by 3. Because this is a stretch of what? 3. Do we understand that? S3 means stretch of 3. Yay or nay, folks?
I just put stretch 3 because I would.
Well, let's see if we're confused on this one. Because it says the table represents the function f of x.
But it's compression.
If g of x is a vertical compression, what's it mean to be a vertical compression?
Going down.
That A is like
That a is a fraction. Okay? So, defined as g of x is equal to 2/3 times f of x, what are the corresponding y values of g of x? So what do I have to do here, folks?
you multiply everything by 2.
You got to multiply every single thing by 2/3. So I have g of x. I keep all of my x's. 4, negative 7, 8, negative 3, 5. And what do I do to every one of those y values? Multiply by 2/3. By multiplying by 2/3, I'm essentially getting a new function. So what is negative 2 times 2?
-4.
-4 is thirds in this case. How about 6 times 2 thirds?
Well, there's 4.
6 divided by 3 is 2. 2 times 2 is 4. -12 divided by 3 is?
-7.
-4 times 2 gives me -8. 9 divided by 3 is?
9. 6.
Oh my God.
6.
Stop talking. 9 divided by 3 is?
3.
Times 2 is? Is everybody with me? 0 times anything is?
0.
0. Do we all understand that? Now, what has physically happened to this function? What did we talk about? What was happened to it? It's compressed by
2/3.
2/3. Do we see that? Yes or no? Okay, well that's excellent because now I'm going to come to this page right here. And you are going to read these functions from left to right. You're going to tell me what each number does to this function. Because they're all one of our families. How many different types of families do we have right now?
4.
What's the first family?
The
The line family, which is y equals x. What's the next family? Y equals x squared, which is the u's family. What's the next family? Y equals x cubed, which looks like? Spaghetti. And the last one? Y equals the absolute value of x, which looks like? The v. Do we all understand this? Yes or no? So, there's all types of information we're going to get from this thing. So, as we run to a number, you have to tell me what happens to that function. So, the first number we run into is going to be 3. What happens to that function? How's it attached to the x? By multiplying. So, what happens to a function when you multiply by a number?
Oh, it's a stretch.
It's either a travel mug or a cereal bowl. Why is it a travel mug?
Because it's greater than 1.
So if it's a travel mug, what is the mathematical definition? Stretch of 3. Go to the next number. It's -2. What happens to that?
Goes right to.
It goes to the right 2 because it's inside the parentheses and you think it's to the left, but it's not. It's the opposite direction to the right. The next number we run into is the little 2. What's that little 2 tell me?
That's going to be a U.
That it's going to be in the parent family of what? X squared. It's going to look like a U. And then the last number is -8. And what does that tell me? That we're going to take that entire function and go down 8 units. That tells you a lot because you know what? I could graph this thing because here's the regular parent function. Now this thing tells me it actually goes to the right 2 and down 8, and this time it's going to be skinnier. Do we see that? That's what that thing would look like. Okay? Now, go to the next one. First number I have is 2/3. What's happening to that?
It's going to be compressed.
It's going to be compressed by 2/3. The next number is?
The left 2, or left 6.
I'm going to go to the left 6 units. Very good. The next number gives me
It's going to be
the little 3.
Spaghetti.
A parent of spaghetti, which is the x cubed. And the last number?
Left.
A
5.
A 5.
a 5.
Okay, do this one quietly by yourself. Silently by yourself. Let me clarify that. Okay, what happens with the 6? The 9? The -2? And what's the parent function? Good job. Do the next one. And you should be able to do every single thing, and that includes the negative. You ready? Okay, what do we got? Someone tell me.
Compress of negative.
Compress of a 1/4. What's next?
Right 5.
Right 5. What's next? Up 8. And the parent function? Anybody else have anything else?
What's with the negative?
What is with the negative? Let's think a little bit. I already taught you guys this.
I just put compress of negative.
Remember we had mountains and valleys? Oh.
No, I don't.
Go ahead.
Oh, okay.
Does this graph look like a mountain or a valley? How do I know if it's a mountain or a
The
valley?
mountain is going down.
Why is it a mountain?
Because it has to.
Because the negative tells me that this thing is going to be reflected over the lovely little x-axis. So if we go to this next page, our next slide here, reflection flips the graph across over the x to y axis. How do I determine if it's the x-axis or the y-axis? Well, this is the part where you guys are going to mess things up, okay? I'm not going to lie. This is the part that gets a little confusing, okay? Reflection over the x-axis happens when you're literally multiplying the entire thing by a negative. In other words, when your a value is negative, then that means you're multiplying by a -1 or a negative times a 3 or 4 or whatever, and it flips it. Meaning if it was a line, instead of going uphill, it's going to go downhill. If it was a U, instead of being a U, it's going to be a horseshoe. If it was a spaghetti, instead of spaghetti going uphill, it's going to be a spaghetti going what? Downhill. Instead of being a V, it's going to be a mountain.
How can you get a spaghetti going down there?
Spaghetti going downhill. This is normal spaghetti. This is the reflective spaghetti.
That's like DNA.
It is. It looks like a helix, doesn't it? Keep going. Okay. Now, if it's reflected over the y-axis, then that means you're going to have f at -x. And we are going to stop here today so that I can go over what I expect out of your homework this week. There are going to be 4 problems that you're not going to be able to do. That we will finish tomorrow in class together to make sure that you have a clue what you're doing.
What's your hair later, man?
In a minute.
You are called blue.
Now, how is each function related to y equals x? That's you're going to be up, down, left, right. Number 3 through 5. Make a table of values for f of x after the given translation. Number 3 is down, number 4 is up, number 5 is down. So if you're moving up and down, does that mean your y values change or your x values change? Your y values change. So all you have to do is keep your x, and then what are you going to do to your y?
Multiply them.
I didn't stretch or compress it, did I? To go up and down, you simply add or subtract. So you're going to add, you're going to subtract 2, add 3, subtract 1.
Whoa.
Now, number 6, it says write an equation for each vertical translation of y equals f of x. Do I know what f of x is?
No.
It could be any one of those 4 parent functions we talked about, right? What I want to do, though, is how do I shift a generic parent function down 1/4 of a unit? If y equals f of x is my parent function, how do I shift that down 1/4 of a unit? I said I want to shift it down. Subtract what?
Oh.
So y equals f of x minus 1/4.
Minus 1/4.
8 and 9, tell me up, down, left, right. Number 10, it says make a table of values for f of x. Well, you see 4 points there, do you not? Can you make an xy table with those 4 points? Then it says do one for f of x minus 2. Well, all you have to do is then do whatever one of those y values. Subtract 2, and then it says to graph f of x and f of x minus 2. The graph of f of x minus 2 should be what compared to f of x? Down 2 units, right? Turn it over, 11 and 12. This is where you have a stretch or a compress. So if you're stretching or compressing, what operation are you doing? I'm multiplying, right? If I'm moving up and down, I'm adding or subtracting. If I'm moving left or right, I'm adding or subtracting within the parentheses. Do we understand the difference? Now, 13 and 14, watch very carefully of the, read the directions that want you to come up with the transformations. 15 through 18 we'll talk about tomorrow. All right? So you guys all should have a clue what you're doing tonight. I'm going to come around here in a minute and get the highlighters.